All right, so chapter 19 is our introduction to the heart and the cardiovascular system. We're going to talk about the functions of the heart, the tissues, the structures of the heart, the chambers, blood vessels, things like that, and the flow of blood through the heart. This is of central importance. You know, when they say get to the heart of the matter, they're saying get it to the most important part. And that's true here as well, that this is one of the most crucial organs of the body. Any interference with the function of the heart is, by definition, life-threatening. So we've had our first introduction to the cardiovascular system when we've talked about blood, the tissue of transport. But blood can't function on its own; it needs the heart. The heart generates blood pressure and ensures that blood flows in one direction through the cardiovascular system. It regulates supply and determines the ability of other organs to function. The very simple diagram you see there shows the heart is really at the center of two separate circuits or routes through the body. The first route is the pulmonary route, which carries blood from the heart to the lungs, where it exchanges carbon dioxide and picks up oxygen. And then from the lungs, the blood returns to the heart, and then the heart pumps it to the rest of the body. So the first circuit is the pulmonary circuit, and the second circuit is the systemic circuit. And so the heart is really two separate pumps linked together. And so that's an important thing. Um, the heart is unbelievable in that it never tires. It's made up of this cardiac muscle, which is a special type of muscle that has striations like skeletal muscle, but the cells are smaller. There's only one nucleus per the cell. They have unique connections that ensure that they don't need a nerve cell to operate every muscle cell in the heart. But like muscles in the organs, heart muscle's involuntary, and it is only able to use oxygen as a source of energy. It can't be anaerobic. Um, the unique feature, the intercalated discs, are shown in the lower right illustration there. There are these little dark lines between the cells. So this is a really crucial feature, that the heart has to have oxygen, that the heart muscles, once one cell starts contracting, that contraction spreads from one cell to another by these intercalated discs. Okay, so here's an external view of the heart. There are two upper chambers called atrium, and they have little extensions called the auricles. Okay, you can kind of see the right atrium. It's the kind of the dull, darker red, and then the ventricles form the bulk of the heart. They're the lighter red that forms the lower part. The very tip of the heart at the lower left is the apex, okay, where the heart is thinnest, comes to a point. Then the base of the heart is actually near the top, where the two atria sit. You can see grooves between the atria and the ventricles. Okay, that groove is called the coronary sulcus. It's filled with coronary arteries and cardiac veins. And then there's a groove between the two ventricles, you can see there. That's the interventricular sulcus. And there's a large artery and vein in there. Okay, the upper picture is the front of the heart. You can see the big arching dark red blood vessel on top. That's the aorta that carries blood to the body. The dark blue vessels on the right side of the heart, the left side of the picture, those are the superior vena cava and inferior vena cava. They bring blood to the body, from the body back to the right side of the heart, and so are going to carry deoxygenated blood. The pulmonary trunk comes off just in front of the aorta. That carries blood from the heart to the lungs, and it'll split into left and right pulmonary arteries. Then on the lower side of the heart, or the lower picture, you can see the back side of the heart. Again, there's a groove between the atria and the ventricles, okay, where you have large blood vessels. You see the right and left ventricles on the bottom. Here you get a pretty nice picture of the left atrium, which is hard to see from the front. And then you can see the right atrium as well. Okay. Here's the upper picture is a picture of the cross section of the heart, a frontal section. So the front has been removed. And then the bottom two pictures are showing vessels and the valves in the vessels. So let's look at the upper picture. It shows the chambers. Starting from the bottom, the apex of the heart, you can see that on the left side of the heart, or the right side of the picture, is a very thick-walled chamber. Okay, and that thick-walled chamber is the left ventricle. On the other side is a thinner walled chamber, is the right ventricle. You can see the right ventricle leads to the pulmonary trunk, and in that pulmonary trunk are a valve called the pulmonary valve, or pulmonary semilunar valve, that ensures that blood that's been forced into the pulmonary trunk doesn't back up into the right ventricle when it relaxes. You can't really see the exit for the left ventricle here. It comes out underneath the pulmonary trunk. You see just a little bit of it where they're pointing towards the aortic valve. Okay, and then the upper two chambers lead into the ventricles. Okay, above the right ventricle, again on the left side of the picture, is the right atrium. That's receiving blood from the inferior and superior vena cava. Okay, and just below it is a flap of the tricuspid valve. Okay, on the left side of the heart, the right side of the picture, you can see the left atrium. Okay, there are two left pulmonary veins that carry blood to the heart that empty into that. There's also two right pulmonary veins that you can't see. And then just below the left atrium, separating it from the left ventricle, is the mitral or bicuspid valve. Okay, so a key feature of the heart, in addition to these four chambers, are the four valves. So there's valves between the atria and the ventricles. These are the AV valves, the tricuspid and bicuspid valves. They prevent blood from backing up into the atrium when the ventricle contracts. And then at the base of the aorta and pulmonary trunk, there are two valves, the semilunar valves. Okay, so let's go through the flow of blood through the heart. Okay, so blood from the body comes back to the left or the right side of the heart via the superior and inferior vena cava. The box is shown in blue because that blood lacks oxygen and has lots of carbon dioxide. That then goes to the right atrium, which also receives blood from the heart tissue itself via the coronary sinus. Blood from the right atrium will pass by the tricuspid valve, and it will enter the right ventricle. When the right ventricle contracts, the tricuspid valve closes, and then blood is forced past the semilunar valve, the pulmonary semilunar valve, into the pulmonary trunk. Okay, this blood still lacks oxygen, so it's shown in blue. The pulmonary trunk is an artery, and it will split into right and left pulmonary arteries that will take that deoxygenated blood to the lung tissues. There it will get rid of the carbon dioxide and it will pick up oxygen, and it will return to the heart via the pulmonary veins. These are veins, but they're shown in red. The box is in red because this is now oxygen-rich blood. The pulmonary veins carry the blood to the left atrium. It then passes the bicuspid valve and enters the left ventricle. When the left ventricle contracts, the bicuspid valve closes, and so blood passes the aortic semilunar valves and enters the aorta. Okay, thereby it goes into the coronary arteries and goes to the heart tissue, or it can go to all the body tissues. I should mention these coronary arteries. They're really crucial. Okay, I said the heart muscle itself has to have oxygen, and those coronary arteries are the first branch off the aorta. They carry the most oxygen rich blood, and they carry it to the heart muscle. They're really, really crucial because if there's not oxygen, sufficient oxygen, that muscle will die. There are also cardiac veins that will take that blood after the oxygen has been removed from it, and it'll take it back to the right atrium. Okay, coronary arteries, if they get blocked, it's very, very serious. Okay, here's an angiogram right here, and it just shows the flow of blood. And here you see a large artery that suddenly becomes constricted. Okay, this is serious and it may cause a heart attack. And there's actually a couple constrictions you can see here. This is when we talk about heart or artery disease, this is what causes that buildup of plaque, which is fatty materials, cholesterol, etc., that can accumulate in blood of people. This is what causes coronary artery disease. And if this is completely blocked, a clot can form here, and this can cause a heart attack. And the crucial thing here is that this causes low oxygen, ischemia. And this can damage the muscle tissue itself. Okay, it can damage the conduction system, which we're going to talk about next time. And so it's very, very serious. Okay, so I went through it fast. You can play it several times. It's really crucial to get all this anatomy to be able to pretty much be able to reproduce this flow of blood through the heart, the description of each chamber, and the position of each valve. All right, see you later.